Okay, so in front of us is the Lenovo Legion 7i. This particular model has an RTX 3060 and Ryzen 7 5800H. Anyways, unfortunately this laptop has no power. If we try to press the power button, you'll notice that, nothing happens. You can see that there's no LED light at the button itself. And you might be able to see that the LED, the charge LED over here, also isn't turning on despite the fact that we have a working charger. So let's go ahead and take the laptop apart and try to figure out what's going wrong. Okay, as you can see, we're looking at the motherboard fully disassembled. I should note that typically speaking at this part we would check 5 volts, 3.3 volts, 1.05 volts for the chipsets, as well as for short, and of course 19 volts after the input MOSFETs. However, in this case, we don't need to do any of that, and that's because it's rather obvious what's going wrong. You may notice that the PCB in this particular area, it's a bit more brown than usual. In fact, let me zoom in a little further. Well, if you're wondering why it's discolored, it's because unfortunately on the other side of the board, we can see that this thing has caught fire. And in particular, this capacitor over here, I have a sneaking suspicion that likely it's actually burned a slight hole in the board and we have to drill into it. But anyways, let's go ahead and remove it and check for a short afterwards. Okay, so as you saw, I took off the two capacitors over here, so the one on the right wasn't necessary, it was perfectly fine, but the one on the left was of course burned. If we now check for a short, you'll notice that we're actually still short, unfortunately, as determined by continuity mode, so 0.3 ohms between the 19 volt rail and ground, which tells us we still have one dead component. Typically, this is the part where I would suspect maybe there's some board layer shorts due to burn damage, but that's not the case here. Instead, it's actually a different component. If we hook up a power supply and we supply, let's say 0.7 volts to our shorted 19 volt rail, as you can see by the multimeter, 696 millivolts. If we check our V-core, we also get pushing 700 millivolts, which tells us that we must have a dead power stage because these power stages are not supposed to bridge the V-core, which is typically about 1 volt at max, to the 19 volt rail, otherwise we'd fry the GPU. So anyways, we have a dead power stage on the board. None of them look particularly off to me, so my two suspects are the ones on the left, but we can confirm which one's dead by just lifting the inductors and then doing another continuity check. So let me go ahead and do that. Okay, so as you can see, I've lifted all the inductors for the V-core, for the GPU. So the next thing we have to do is we want to confirm which one is, which power stage is dead. So we're going to take our red probe and put it on our 19 volt rail, which we can find at this capacitor here, and then check for continuity to the first inductor pad over here. I'm not too sure, actually, hold on. Anyways, like I said, to the very first inductor pad, just after the power stage. So we're going to go one by one, but I already know which one is dead. So checking the first one, we have 10 kilo ohms, that's fine. Checking the second one, 0 ohms, so we can trust that this one is dead. Checking the third one, 11.6 kilo ohms. Checking the fourth one, 25 kilo ohms. And checking the last one, 10 kilo ohms. So this one's abnormally high, and this one is, well, short. So anyways, let's go ahead and remove this, and then see if our short goes away. Okay, so as you saw, I replaced the power stage as well as the two capacitors on the back. So if we check the resistance on our 19 volt rail, unfortunately we have a rather low 23 ohms. So we can tell that there's still another problem. So as far as I can tell, it's related to this power stage again. I think maybe there's either some damage under the board or this particular part is just plain dead. But in either case, let's take it off and do a more thorough inspection. Unfortunately, the audio doesn't work from my microscope footage, so I'll just have to narrate over it. But as you can see, we do have a PCB layer shorts just under the power stage. I'm a bit surprised. I'm actually kind of embarrassed that I missed it to begin with, but at the very least, we did catch it. So as you can imagine, I have to drill into the board, and that's the finished product. And of course, after I drill into the board, I then have to cover it with PCB mask. I should note that due to its location, this is a bit troublesome because if you drill away too much, you could potentially compromise the integrity of the board and cause problems down the line. Thankfully, this is not going to be the case, as I did actually get it repaired. But obviously, after that's done, we put on the power stage and any missing components, and we should be good. Okay, so as you saw, I replaced the power stage over here, as well as drilled a hole under the board to clear the PCB layer short. So, the final thing we have to do before we put this thing back together and stress test it is to confirm that the power stage actually works. So we're going to do this by checking the wavelength of the output of the MOSFET, or power, I should say power stage, at the first inductor pad over here, and we'll compare it to a working one like this one over here. Anyways, let me go ahead and turn on the system itself. So turning the system on, and yep, it's on. Checking that first inductor over here, we're good. And checking the second one, yep, we're good. So we're done. Okay, as you can see, the laptop now works. If you're wondering, it's been under load for about 8 hours, not 8 hours straight, just 8 hours in total. This session has been about 2 hours long. So anyways, as you also saw, we had a dead capacitor, we had a dead power stage, and we also had a board layer short. I would say the short was about 4 layers deep, maybe 3, and not very wide, thankfully. It could have gone a lot worse. Most time when a power stage dies and catches fire, the crater it leaves is typically much bigger and much more problematic, but thankfully not in this case. If you have a broken graphics card or a broken laptop or just broken anything and you want to send it to me for repair, I have a website, www.techcenter.com, where you can submit repair requests and ask for quotes. I look at basically anything these days, as graphics cards are kind of stale to me at the moment, and I would love to look at, let's say, another laptop, as they're quite fun to me at the moment. Anyways, like always, I hope you learned something watching this video, and if my videos on my channel help you out, consider subscribing to me on YouTube and telling a friend about me if you know a friend with a broken electronic, as that definitely helps. Otherwise, thank you for watching, and hopefully I will see you in the next one.